Hello, everybody. Here are at episode 9 of Vroom Vroom Go. It was the February game of the month, which is just a multiplayer car game. So, I know it's March, but we're still working on it. Unity 5 is out now, so we're going to start off by upgrading our project to Unity 5 with all the new engine features being free to everyone. We're going to be probably adding quite a few new things, maybe not necessarily in this tutorial, but over the course of the next few months. We're probably going to be adding quite a few things that used to be advanced only, or I guess Unity Pro only, to our games, because, well, everyone has the ability to add those now. So without further ado, let's just jump right in. Alrighty, so the first thing we're going to do is go ahead, jump into your browser of choice, navigate over to unity3d.com. It's automatically going to drop you on 5. But they have this nice little big button that just says Get to Unity. And we'll notice here, as it says, you get all the engine features. Just go ahead, download it. Put it anywhere you want on your system. Of course, make sure you get the version that's appropriate for your system. Right now, I'm on Windows, so I'm going to go ahead and install it on Windows. And you should already know how to install an application if you're following along with this tutorial series. And let's just go ahead, after it's done installing, open it up and upgrade our project. Alrighty, so now that we have it installed, let's go ahead. We'll jump into Unity. We're going to go ahead, open this up. And we got a little bit new of an opening screen here for Unity 5. I've gone ahead and covered this already on our live stream and a few of the videos on the channel already. But basically, we want to just focus on our one project. For me, it was called Vroom Vroom Go. So go ahead, open up the path to your actual application. Unity 3D, here we go. Of course, the way I have mine stored is I actually like to have my Unity project inside of another folder called the exact same. So a lot of the times you're not going to have to go dig this deep down. I just like to have that extra layer of folders to put source material in there instead of stuff that isn't actually part of my project. But we'll go ahead and open it up. You'll know you're there when you get the assets library and project settings. Just hit select folder. And before you actually do this, make sure you do make a backup just in case something goes wrong. I have a backup already, so I'm going to go ahead. It'll tell us that it's going to upgrade, so cross your fingers, I guess. We'll smack that button and we'll just wait. Now, it shouldn't take that long as we don't have that much in there already. But once it's done, it's going to go ahead and open up your project for you. Oh, here we go. Here it is telling you to make sure that you've made a backup. It's going to update any of the API stuff that needs to be updated. Like I said before, I've already got my backup, so I'm going to go ahead and start this bad boy up. And I guess we'll just hold on as it tells us. All right, so we got a few errors here that showed up. Terrain splat 0 is null. Go ahead and clear this. And to be honest, I'm just going to close the application and try opening it again just to see if those errors still persist. Now that we've already opened it before, it should automatically show up on the top of your list. We'll go ahead, we'll start this up. And I don't have any more errors, so I'm happy with that. We're going to go ahead and test out the scene just to make sure that it does work. Here we are in our demo scene. I'm going to go ahead and start the bad boy up. Take a look here. And we've started. And let's go, we'll find the car. Now, I've already done a little bit of testing. That's the car we have in there. And I noticed that some of the physics are different with the wheel collider. The car seems to be a little slipperier, I guess. We seem to slide a bit more, which is fine. I actually like the effect, but we might actually have to go over our wheel collider again. I'm pretty sure that's what it is that's acting different. We do have a new physics in Unity. And if you notice here, my wheels are rotating. You can see the actual, zoom in there, line at the bottom. So my wheel colliders are rotating. We'll have to fix that with the graphic later on. But anyway, as I was saying, it does feel like we're a little more slippery. We slide around a bit, but we can go ahead and just adjust settings to get it to where you want anyway. Everything's still there. You just got to play around with the settings. All right, so I'm happy that this is working. Let's go ahead and open up some of the scripts. So I'm going to go ahead, start off with our network player. We'll go ahead, we'll open that up. I'm using actually Visual Studios this time around. So the font should be good. Let me know in the comments below if it's not big enough. I think it should be big enough. I'm running in 1080p with the font slightly bigger than it used to be. But let's go ahead, we'll just jump in And actually, I think what we need is the other script, network manager. Nope, actually, it's the network player we need. All right, here, right here is where we're spawning in our network. So keep in mind, the network view.isMine means that it's my local player, as in the person who's playing their machine, and the else block will handle all the people that are, well, the network players, the people you're playing against. So we're gonna go ahead, take a look at our car again. I've got it up here, so let's go ahead. We'll just start doing things like this rigid body. We're not going to need gravity on our network players. We just need them on ours. So I'm going to go ahead. Let's enable the car. We'll disable the gravity. We'll go ahead. We'll reapply it. And I'm just going to do one at a time here. We'll jump back into our script. And let's go ahead and actually turn that on. Get component. The component we're going to want is a rigid body. And let's say use gravity is equal to true. Well, there's a couple of ways we could do it. Oops, I'm getting silly with the key. There's a couple of ways we could do this. We could actually turn around and just turn it on, like have it turned off on our prefab, then go ahead and turn it on when we spawn our character. Or we could have it on by default and then turn it off for our network player. Now, you're going to have probably more networked players than you are viewed. There's only ever going to be one of you. There's going to be multiples of them. I just like it this way here because when you first spawn in, it turns everything on. You don't have to worry about any sort of performance hit, depending on how many things you have to turn on, turn off. Where network players, maybe they're spawning in and out as they're playing. And it shouldn't really make that big of a difference with our application, but I like it this way anyway. But when we get to making our own prefab, we'll probably be changing all this around then anyway. So let's go. We'll jump back into Unity and see what's next. So I'm just going to go down the game objects in our car prefab and just turn things on and off that we need. So nothing here. That's just part of the mesh. When we actually create a new car, all be part of one mesh. But anyway, we'll go ahead. Center mass, we don't really need, but we're going to leave it there because we have scripts that access it. We'll leave it there for now. Let's jump on the front axle. We don't need the sway bar anymore because that's going to be controlled on the local player's machine. So the network player does not need that. So that means we've got to grab the front axle and the rear axle. And let's also take a look. Can we just disable the axle? That would disable the wheel collider, the wheel script. That means the wheels won't turn for now. Let's see, what do we got here? We also have the front left wheel. Oh, the tire. We won't be able to get the tire. Well, for now, let's just go ahead. We'll disable the sway bars. We know what type it is, and we're just going to go ahead and find them in our script. So we'll go ahead, we'll jump back into Visual Studio, whatever your scripting ID is of choice, and let's start there. Okay, so we're going to want to go ahead and get a reference to those sway bars. So let's just go ahead and grab all of them all at once. So we're going to create an array. I'm going to call it SB, short for sway bars, and we're going to say is equal to get components in children. The one we actually want here. If we take note here, it returns an array of components and we just tell it what type we want. And of course we want sway bars. After that's done, let's just simply iterate through them and turn them on. Now by default, we're gonna have to go turn them off, but we'll go ahead, we'll turn them on here. I'll just make a for each loop. For those that don't know, a for each loop is similar to your typical for loop, except it enumerates through it. You basically don't need a counter. It automatically knows how many are in there and it'll go through it for you. And the syntax for it is pretty easy. So you say for each and the type of whatever it is you want to go through, which is sway bar. And we have to give it a name for what we want to iterate through, what it's going to reference it as. Let's call it bar. And then we tell it what to iterate through. And in this case, we want to go through that array that we just created called SB. And all we're going to do is come in and say bar dot enabled equal to false. There we go. We'll go ahead. We'll save this off. We'll go back into Unity. Let's select our car. And we'll go down to these axles. And let's go ahead. We'll turn them off by default. Oops. So I don't want to turn the axle off. I want to turn the sway bar off. My bad. That's off. That's off. We'll go ahead and take our car. We apply it. Turn our car off so we're not screwing around with it. Start our game up. And when it starts up, it should be there. We'll take a look here. And did I set them to false? Let's check. I did. What I really meant was true. And we'll go ahead. We'll start this back up. Take this bad boy out. And we'll just iterate down through it. And there we go. They're turned back on for us. And I like just to make sure that my car is still working. There we go. Vroom, vroom, vroom. Woo. Okay, well, our car is still working, so let's go. We're going to stop that there. And let's go ahead and do a build. And let's see what those changes have done to our network cars. I'll come down to build settings. We're just going to go ahead and build a standalone. I have to do my 4-bit version. Windows. Make sure we get Windows. I am on Windows. And let's just go ahead. We'll hit build. I'm just going to throw on the desktop so I can delete it quickly after. Save that off. It'll compile those scripts. Now, I find generally the first time it takes a little bit longer than the rest of the time. I guess it's depending how much updates you do. But we're going to have, we'll build this out and we'll see what it's like. Alrighty, we got it built out. We're going to go ahead. We'll start the deck up. Yeah, we'll go ahead. We'll allow that. I want to make sure it's windowed. And I'm going to pick a smaller resolution. 8x6 is good. I don't care about the graphics quality. And we'll go, we'll display it here. Apparently picking the monitor doesn't matter. So we got it going. Okay, and control it. Let's go ahead. We'll start up our local player. That down. Woo! Alrighty, so we'll go ahead. We'll use the remote player. There we go. Get him moving, and I lost him. Bit of a collision there. And as we can see, we still need to do some work. We notice the car is bouncing everywhere. So let's go ahead and actually work on some lerping to get the car a little bit smoother than, well, what it is right now. Boing, boing. So we're going to go ahead and jump back into our script. And if we come down here a bit, we'll notice I've added a new function here on Photon serialized view. I always spell this wrong, so I went ahead and put it in there automatically. This is provided by the Photon model behavior. And think of it as just, you know, like on start, on awake, on update. These are just methods that are provided from model behavior, or in this case, Photon model behavior, that things happen and you can just do stuff inside of it. Magic. All right, so it does take two variables here. One is the stream and the other is the info. We're going to focus on the stream. So let's go ahead. I just want to make sure that I'm actually looking at this script in our Photon view. We'll jump over to Unity. I'm going to take a quick look at my car here. Come down to the network layer. That's the script. The Photon view. And if we take a look here, what we're observing the transform. We're actually going to switch this over. We're going to observe the script. And this way here, that method that we're working on now, this is basically how we can tell it what to, well, basically how to look on the other person's screen. I'm going to go ahead, activate that again, apply it, deactivate it, and we'll jump back into our IDE. And well, let's just start off here. Now, if we take a look at stream, we notice a few things we can take a look at, like count, data, is reading, is writing. These are the ones that we're actually going to be using the most right here. And of course, we also have send next. And the other one should be receive. There we go, receive next. Those are the ones we're interested the most in. If you want to look at the rest of these, go ahead to the Photon documentation. They'll tell you how to use it. So start off. First, we want to start off. We want to know, are we going to be writing to the stream or are we going to be reading from the stream? And we can do that pretty easily with an if block. We could probably actually do a switch block as well. I'd attempt to do that, but we'll just go ahead and stick with this here for now. If we end up adding another one in here, I'll probably switch over to a case block. So we're going to start off, say is stream dot is writing. So are we going to write to the stream? Are we going to be telling other people basically what they should be viewing when they're looking at our network instance? And I'm also going to have an else. And right now, there's only one thing that could be happening during an else. So either going to be writing or we're reading. Well, first look at writing. Now, we'll just simply tell it to, well, go with this first. The order that you put things in here, as far as is writing, you need to have it in the same order for reading, or things are just going to get all screwed up. So only thing we want to send in right now is our current transform and our current rotation. That's all we really need to set. So we're going to go ahead and do stream dot set next, and we're just going to tell it transform dot position. Pretty simple. Of course, stream dot send next, transform dot rotation down here at the bottom. And then down here, basically we're going to say if this is a networked player on someone else's local machine, we have to tell it to store these variables. So we're going to go ahead and just start off at first saying transform.position is equal to what we want to pull out. So stream.receive next. Like I said, order matters. So we're grabbing the position because that's what we stored first. And we have to make sure to typecast. This is pulling out as an object for C#. So we're going to say that this is a vector 3. And I'm just going to go ahead and copy paste this. And we're going to grab the rotation. And this is not a vector 3. This is a quaternion. We'll go ahead, we'll save this off. And this isn't going to make it smoother. Basically, all we did with these few lines of code is tell it to monitor only the position and rotation. So instead of grabbing it from up here, it's grabbing it from our script. But it allows us to expand on it later so we can add more to it. And of course, we're going to be lerping to make it a little bit smoother. Well, let's do a build just so you can see exactly what's happening. I'll just save it to the same spot. I don't mind if it replaces it. And like I said, usually the second time around, it builds much quicker. On my other monitor here, but we'll go ahead and open it up. I'm going to keep the exact same. This one this time. Hey, this is actually monitor 1. I don't know why it's saying it's monitor 2. But we'll go ahead. We have our car. I'm going to grab my local instance, start it up. It should behave exactly like it did before. Great. And we notice it's bouncing around. And if we grab our other car, the exact same as before. But like I said, now we have the ability to have more control over it. We'll go ahead, we'll quickly shut these down. And let's jump back into our IDE and start with the lerping. All right, so if we come down a little bit more, I've gone ahead and actually made a comment down here. And we're going to go ahead and create a state machine here. And we want the state machine to run while we are alive. So we'll go up to the top and we're going to make a few variables up here. First one we're going to make is a bool. And these can be private. There's no reason to have them out there. Of course, with the private C#, you don't actually need the private. Let's say bool is alive. And of course, we'll start this off as true. And we're going to have two more, one to store the position that we're getting from the network, and one to actually store the rotation as well. So we're going to go ahead and store those off as, well, we need a vector 3. Call it position. Oh, not the other one isn't a vector 3, it's a quaternion. And I'll just call this rotation. All right, we got them both saved. They're going to be initialized to their default value, which is 0. I'm going to come down here. And when we're reading from it, we're no longer going to be storing it directly into our transform and our rotation. I'm going to store it into those variables that we put there. So we'll start off by position to, well, our position that we're getting from the network. And of course, we're also going to say rotation is the rotation we're getting from the network. Great. We'll go ahead and save it off because just in case it crashes. Now I'm going to come down here and create this, well, basically this state machine. And because I don't want it to hog up all the resources, we're going to go ahead and make this a coroutine. We'll start off with an I enumerator, and I'm just going to call it while alive. Would be a good name for this. I'm going to run while we're alive, so call it alive. And I don't need to pass anything to it, at least not yet. So I'm going to go ahead and create my switch case in here. Is alive. We're just doing a while block as well. Which one do I want to do? Let's do the while block. While is alive. Go ahead and take our transform, position, and just to make it simple, we're going to go ahead and make, well, no, we'll do the lerp. We'll do the lerp while we're here now. What we're going to use is a vector3 alert. If I spell it right, that. It's already built in there for you. Just alert. Go ahead, we'll open it up. It takes two parameters, as you can see here, the from and the to. So basically where we want to go from to where we want to go to. So the from position is our current position, and the to position will be the position that we're actually getting from the network, because this is working for the network player. So basically where the network's telling us that we should be, this is where we want to alert to. And then a third parameter that's passed in is basically over how much time do we want to do this on. And we're going to use time.delta time, and we're going to multiply it by something. And we're going to come up here, and this is basically just how smooth it's going to go. And we'll make it a float. You'll want to play around with this value just to see, how smooth you want it. Now keep in mind that the greater the number, the smoother the animation or the movement will seem. But the less accurate it is, but shouldn't really be that bad. I'm going to start off with, what are we going to call this? Alert smoothing. And I'm going to go ahead and start mine off at 5. Put an F there because it is a float. Copy it down here. Put it in. Paste there. And we'll go ahead, we'll end that off. And then we're going to come down and do the exact same thing for rotation. Except this time it's going to be equal to a quaternion dot alert. And it works the exact same way. We want to take a from position and a to position. And of course, the from position is still going to be the one that we are ourselves at. And the to position is the position we're receiving from the network where it's telling us that we should. And of course, I'm going to do the exact same thing here for the smoothing part. We'll do time.delta time. And we're going to go ahead and multiply it by our alert smoothing. So this is an I enumerator. We want to go ahead and make sure that we have some sort of yield statement in here to get out of it. So yield, return, and we'll just do a null. We don't actually have to return anything. And make sure you spell yield right. There we go. We'll go ahead, we'll save this off, and we actually need a place to call this. And since this is only something we want to go when it's a network player, the perfect spot would be up here. We'll go ahead, we'll start a coroutine. And the coroutine we want to start was, what again? Alive. We'll go ahead, we'll save this off. Let's go ahead, we'll jump into Unity, see how many errors we have. And of course, if we did everything right, there should not be any. So let's go ahead, we'll create our game one more time. I'd hit that build, save it off. Yep, we'll go and replace this. Bad boy open up, and everything should actually be running quite a bit smoother. This time around, I'm actually going to start with our local player going. While that's going, I'll go ahead and start up our other player over here. Here we go. We landed on him. Let's go ahead, we'll turn around, and if everything's working right, up on a hill. We can't fix this. Get him moving a bit. Back in. Around, see if we can't see him. Something's really funky going on, so we're going to have to go ahead and take a look at our code here. So let's go. We'll start this back up again. I think it just might be something we're going to have to look into a little bit later on. I'm not sure. Maybe it loaded up a cached version. I'm not 100% sure. We're going to go ahead. We'll start our remote up and then our local. And if we go ahead, take a look here. Whoops, we just ran over them. Not quite seem to be updating correctly. Because this is in the background? No. Oh. Let's go ahead. We'll take a look at other player. Whoops. Well, he doesn't seem to be positioned right either. Let's try it one more time. I guess we'll leave this till the next video. It gives me something to work on. Should not be doing this though. Previous test did not do this. It was actually fine. So I'm back up. Move this over here. The issue is when we collide. Starts getting all crazy and bouncing around. So it's something I'm gonna have to look at, I guess. See where I changed the code from my previous game. But he does move smoothly. Whoops, I went too fast. Back this bad boy up. And if we just go ahead and take a look here, he's moving much smoother. And like I said, if you want him to be even smoother, you could increase the lerp. But I'm not sure why we're floating on some screens. I'm going to go ahead and take a look into that for the next video. But this should give you an idea of how we're going to go about getting everything synchronized. And I guess I'll see you over the next video. Thanks for watching. Bye-bye.